So welcome. Thank you for staying late at the last session of the day. My name is Shaun Smith. I'm working on GraalVM, and I'm going to talk about building small containers. And I put up an outrageous statement about a 1.5 megabyte application, Java application in a container, and we're going to see that. I'm excited to be out of the house for the first time and going to conferences, so I'm at Devoxx again. I went looking for slides. I was at Java Polis 2005. Do you remember the questionable spoons? Yeah, so this is the old days, you know, because it was landscape, portrait mode, right? It's square. Now we're in landscape. Anyway, I thought it was fun. So let's get started. So I'm going to start at the end. I'm going to first prove the claim that you can do what I suggested you could do, and then we'll sort of go backwards and see how we get there. So I'm going to use hello world because that's what we use, right? So this is the simplest application I can think of. I guess I couldn't do any output, but I know the compiler will optimize it out of existence if I don't do something. So I'm going to use hello world. And what we're going to do is I'm going to use GraalVM to take, I'm going to Java C the hello world application. I'll create some bytecode, a class file. I'll run it through the GraalVM Native Image utility and generate an executable. In my case, I'll generate an executable for Linux. And just if you haven't used GraalVM before, I just point out that you're using GraalVM now. The Devoxx app is written by Johan Voss and his team at Gluon. It uses GraalVM under the covers, JavaFX for the UI. So if you have never tried GraalVM, you're wrong. You probably have tried GraalVM if you downloaded the app. So let's go look at a demo. Oh, that's not the demo. That's the demo. OK. I like Devoxx because this is no one in the back is going to say, can you make the font bigger? Right? This should be good. All right, so hello world. That's readable. OK, it's not too bad. Even I'll actually make it bigger still. So this is hello world. What I'm going to do is I'm going to show you the build file just to make it easy for myself. I'm going to Java C the file. So I'll get a hello.class. I'm going to run it through native image, and I'm going to explain. I'm not going to explain all the details right now. We'll back up, but this is the sort of the cake from the oven part, right? I'm going to run it through native image. I'm going to say statically link it. I'll explain that later using musl. Output file is called hello. I'll get a binary called hello, and then I'm going to use UPX. Anyone use a UPX? It's a compression application. It takes a binary, Linux binary, Mac, Windows, compresses it, and basically gives you a, when you run the application, it actually runs UPX as a stub. It then decompresses your compressed application and runs the application. So it's a way to squeeze your application small and distribute it. And then I'm going to put a Docker file. And the Docker file is going to be very boring. It's going to be from scratch. So it's very empty. I'm going to copy in that executable and just run it. Right, that's all that's going to happen. So let's just go over and do that, and we'll see some numbers. All right, so I'm just going to run that build. Okay, so Java C runs, then GraalVM Native Image utility runs. You get a lot of information here about what it's doing. So GraalVM, when it's running a native compilation, it starts at an entry point, like the main for your application. It walks through, does a static analysis of everywhere it can get to from that main. So all the classes, methods, fields that your application touches. Okay, now this ran pretty quickly. GraalVM ran, the compiler, and then UPX ran. But let's take a look at some of the data here. This is what's kind of shocking. So the output shows you that your hello world, you touch 3,092 classes. You can't imagine that hello world needs that many classes, but in Java, you talk to strings. Strings have string format. They talk to, I mean, it goes on and on. There's this chain of connections. Transitive closure of classes you can touch is huge. 3,700 fields or so, 21,000 methods, all reachable. What's interesting with GraalVM Native Image is you may encounter classes where you don't need all the methods because you don't use them, or fields even of classes that you're using you never reference, and they can be optimized out. So the machine code you get out of GraalVM Native Image out the back end may not have certain fields, will not have certain classes, will not have certain methods even on the Pru's code. Anyway, we ran UPX. It shrank it to only 24% of its original size, so it's shaved it down quite a lot. And I'm going to just clear to go to the top of the screen for you in the back. Let's take a look at the size of this here. Okay, so let's take a look. So I've got an executable, hello. It's a whopping 6 meg. Okay, and I have a compressed version, hello UPX. Let's just run that. Run hello. It says hello world, right? I run the UPX version. It says hello world. I can run the Java class because the class is there too. So Java, hello. All the same. What's interesting is the time. And I'm not going to focus on this today. I just want to show you this. This is kind of interesting. So if I run how long it takes to run Java hello, it's about 61 milliseconds, 50, 60, okay. If I time how long it takes to run the hello app, the binary, right, the compiled version, it takes 2 milliseconds. So it's the same application, compiled to machine code, same Java applications, taking 2 milliseconds. So what is that? What's the difference? 1/30th of the time. Now the UPX version, and the UPX is a bit of a party trick. Okay, so I'm not saying you should use this because there are some. It's small, but it's a bit slow. So if I time that, the UPX, the hello.upx, that version, 120 milliseconds. So it's quite slow, right? Because that decompression is expensive. So this is an interesting topic for us in the GraalVM team. We like compression, but we don't like the slowness, so we're looking into that, right? So we have some ideas about that. Oh yes, and of course there's a Docker container. So I did, up there somewhere, you saw a Docker container being run. Here you go. So I've got one, and I'll run it, right? Docker run. Hello, I think it's UPX, isn't it? Hello world. Okay, so that container image, Docker images, if I could type standing up, Docker images. I have a bunch of them, but here's hello, right? It's 1.5 megs. Okay, so I've proven my point. I guess we're done. This talk is over. No, so that's interesting, right? It's a Java application in a container. I can deploy that. It doesn't do anything, so that's why we're going to move on to some more interesting things. So that's a bit boring. So let's go back to the slides. Okay, so what we saw there was this tiny little application in Scratch. And I sort of set out to see how small, what's the journey to building a small Java application in a container. So the smallest sort of off-the-shelf container image I can find with JDK was distroless from Google, just distroless Java. They have an 11 and 17 version. It's just the JDK with minimal support library. So it's basically JDK in a container, 231 meg. So naively, and a lot of people do this, you might use something really large like that to start with. So what's in that big container? The full JDK, right? So all the JDK modules you're probably not using. JVM, Java-C, all kinds of tools in there. All the shared libraries. If you go poking through the JDK, you'll find a bunch of shared libraries they need. And then the base OS image and all kinds of libraries and utilities in there. Now, the distroless container images are stripped down. They're designed to not have a lot in them, so this is pretty good. 231 is pretty good. It's smaller than I could create myself, starting from just the JDK and some other container image. The native image, I just have the code I need. All those modules, all that stuff, I know I don't need it for Hello World. I have just what I need. My code, any independent library code, I've got that. Any static libraries I needed, I statically linked them in. So that binary has all the libraries. I'm not depending on the environment for anything. And it's just in Scratch. It's just me, and it's just my application in not much else. So that's why it's so small. So let's go to the beginning and see how we get here. So I went looking for the smallest possible web service or service I could build. And I realized the JDK has a service built in. So in 18, we started shipping the simple web server. It's in the jdk.http server module. And it offers a simple web server. So if you run it, and there's a command here in this JWeb server, you see here. So it's in the JDK. If you type JWeb server with your Java home on the bin on the path, it'll boot this up. And it basically starts farming out files, right, serving files. If it finds an indexed HTML file in the folder you're serving, the folder you configured it to, it serves up that file. If you don't, it lets you wander around the file system. Super insecure, but useful for development, right? So we can take this and make it into a web service. I'll put it in a container. So I don't need any classes. This is the first demo where I've never written any code, and I have a full web service. It's in the JDK, and it's kind of hidden. So naively, I might go, well, I'll get DB in 11, a small, right, slim image, it's about 80 meg, and I download the JDK, I unzip it, 17, I got about 303 meg. I put it in there, and I can just sort of type JWeb server, right, boot it, and it'll run. So that's 385 meg. It's a pretty big image. A lot of people do this. I gave this talk last week, and a lot of people said, confidentially afterwards, I'm doing this. I have these gigantic Java containers. So hopefully this is a useful talk, because you can do better. So There's more than one set of small images. Red Hat makes some. There's the distroless ones for Google I'm going to look at today because they have a nice range we can look at. And these distroless images, so-called distroless, which are not distroless, they have Debian in them, contain not much. Just enough operating system and libraries to run your app is the goal, right? It reduces your attack surface area, improves your footing for security, and they're smaller, which is also useful. So if you haven't seen these, you can take a look at the web page. Just Google distroless Docker and you'll find the page. So they have an image called distroless Java 17 and they have Java 11. It's a bit smaller. It's 231. That's the one I showed you at the beginning, right? It just contains the JDK and they've trimmed it down. So I could just deploy this and I can run JWeb server and serve up files in a container. That'll work. This is a container image. But that's not the greatest. So you shouldn't ship all your code, right? We're being told don't ship the JDK. You should use JLink to produce a custom JRE that just contains the modules you need for your app. And when you do that, it gets rid of Java-C. It gets rid of all these things you don't need for runtime. We haven't had a JRE since 9 because JLink does basically build you a custom JRE. So let's just take a look at that. So, well, before I do that, what's interesting is I can run this on Java base. There's a distroless Java base. It's a container image that contains Debian at the core and just the libraries that the JDK relies upon, right? So they basically just said if you look through the distroless issues on GitHub, you'll see someone asked for this, saying, I just want to deploy JLink. I don't need all this stuff. Just give me what I need, and they came up with this Java base. So let's just go over there and take a look at JLink. So here's how I build JLink. It's just JLink module path. This is the modules I want to include. In my case, I have one module, and it'll pull in Java base. And then I have a bunch of stuff that tries to just make it small. So throw out the header files, no man pages, no debug stuff, like strip out everything I don't need. I want a custom JRE that's quite small, and spit it out into a folder here called JWeb Server JRE. And then I'm going to put it in a Docker container, and I'll show you the file here. The container for JLink is this, right? So I got that Java base Debian. I'm going to copy the thing I produce in there, and then I have an index file, so I have a simple file, right? I copy it in there, and then I say run JWeb server. This is this is the utility that's provided, right? This little wrapper, listing on the ports and serve up what's in the web. So let's run this thing. So it's pretty quick, right, to actually spit out the JRE and build a Docker container. It's good, so let's just take a look here. Oops, that's not right. Okay, so 74 meg like advertised. We can run it. I always forget to map the port. Got to map the port because it's going to listen on the port. It listens on 8,000 by default, and that's JWeb server. Actually, you know what? It's right there. Why type when you can cut and paste, right? So it runs, right? That's not really surprising. Let's just go and we'll call it here. I'll just curl it. Curl localhost 8,000. So my hello world index page gets served, right? So this worked. This is good. So that's not too bad. 74 meg isn't bad, but we can do much, much better. So now we'll use GraalVM Native Image. So what I'm going to do is compile that module down to an executable. And so what's going to happen, we'll start from the entry point, which is sort of the boot entry point for that web server, that module, and walk through all the classes we need and include just them. And we have this little piece, this little green bit here. SVM is substrate VM. It's really just our runtime library that your application is going to need. So we can generate the code for your application, but you're going to need the garbage collector. You're going to need file I/O. You're going to need all kinds of stuff. There's libraries that the JVM provides you and services. That's what SVM does, fairly small. And then in the container image, I still got these libraries that the JVM needs. That's why I'm using this Java base. And you're on Debian. And so I'll compile that down to like 20 meg and put it in there, and it's like 58 meg. So I'm just going to do that first off so you can see this file run here. This takes a little bit longer. Okay, I gotta kill this. Hang on, Docker. let's just stop it, right? 22E. Okay, good. So what I'm going to do here is I'm going to build the dynamic. This takes a little bit longer. So native image time depends on the size and complexity of what you're feeding it. So I fed it before Hello World pretty quick. This has got more classes to look at. There's more going on, although it isn't that much more. So in this case, 5,200 classes. It's not too bad. Before we saw about 3,000 classes reachable. This takes about 25 seconds or so. But at the end, we'll get a binary, which we can actually try running on here. So we've had a lot of improvement in GraalVM Native Image in the last year. So it's building faster, producing smaller executables, and especially requiring less memory. So we had a problem where like you run GraalVM Native Image, and it would like really need a lot of memory. And if you didn't have a lot of memory, that was a problem. We've got down to where it certainly runs within a GitHub action. So about 6 meg. Is it 6 meg? It's 6. Yeah, 6. So it'll run in GitHub actions if you're doing some builds in GitHub. Okay, so I could run that. So actually, let's take a look here. Jump to the top so we can see it. That's JWeb server, the dynamic one. Okay, a 19 meg. Just to show you what it's got, if I LDD that, which is showing you the libraries that are linked to it, you see a bunch of libraries. So it's a Linux executable with a bunch of libraries. Most of this is glibc. So I can boot it from here, right? And it works. And it would work the same. I'm not going to go through it, but I put in a container, and the container is basically, as we saw, that's the size I advertised. So it's not super exciting, but I've now taken that same service, and it works. It serves up files, right? Listens on ports, and it's only 19 meg. So let me just stop for a minute and sort of talk about linking. So this is where it's a bit interesting. So in GraalVM, you're building a native executable. So far we saw dynamic linking. I said compile my code, and I'll pick up everything up from the environment. So that's sort of on the left, right? So the fully dynamic, just my code is going to be in the binary. Everything else I need is outside the binary. On the other side, we saw that Hello World. Originally, we saw the fully static, where I linked in everything. It was a completely standalone. If I did LDD, I failed to do that. But if I do LDD on that, it would say not a dynamic executable. There's no libraries. It's just shrink wrapped. And the middle is interesting. It's a strange term, mostly static. We're going to link everything we need except glibc. A couple of reasons. One reason is that glibc shouldn't be statically linked. If you try it, I've tried it, it kind of doesn't work. It'll fault on you. There's some bugs to do with concurrency that are not fixed. They're still sitting there in Bugzilla, so that it doesn't really work. The other thing is it's GPL. So if you link glibc into your code, you're basically infecting yourself with GPL. So they keep it as a shared library, and that's all fine. So don't link glibc. You'll notice on the right on static, when I do static linking, I'm linking in musl. So we use the musl library for static linking, which is MIT. So it's safer. You should consult your lawyers, okay? But safer. So the line is just what's in the OS, what's in the app, right? So we're going to just sort of walk through these options, right? So if I go to mostly statically linked, right, mostly, then I can link in the required libraries into my binary and leave glibc out. And that lets me move to yet another distroless container image that's available called base. So distroless base contains what you see. It contains Debian core runtime and glibc. And that runs about 20 meg. So glibc is like 20 meg, basically. Well, you'll see in a second, around 20 meg. I can do this. I'm down to like 39 meg. That's not bad, right? So I have an executable plus a smaller base image. I'm going down. The question of Alpine comes up. People go, oh, I want to run Alpine. Sure. Alpine works fine, right? It's lightweight. It has BusyBox in it. So it actually has a shell, which is probably a bad idea. But you can run it on Alpine. Alpine's small, 5.5 meg. It works if I statically link the app, though, right? There's no glibc. There are versions of Alpine with glibc in them, which seems kind of pointless. But I can statically link my application, and I can run it on Alpine, and I'm down to about 25 meg, right? So it's pretty good. But I can still do better, and we'll go and do that. So if I go back to distroless, there's distroless static. And it's basically like Scratch, right? It's like nothing in it, just enough operating system to run your application. It'll boot your app. It does contain a few things. So the distroless, what's interesting about distroless is they do contain things like well, it depends on the version, certificates and other things you might need for web services, whereas other container images may not have that. So you may have to copy more in. So if you're going to work with a very, very like stripped down container image, you may be required to copy more into that container image for your app to actually work. My application is very, very boring, so it'll work fine. So let's go off and build this and take a look at what that looks like. So let's go back over the code here. So the build for this, let's see here. Fairly straightforward. I've got some path stuff set up here for musl to work. Same as we saw before with hello world, very similar, right? Native image, static, musl, this is the module, this is the output, and then I'm going to copy into a bunch of files. But what I'm going to do is I'm not going to build these. I'm going to show you. I'm going to go one more step, which is go back to Scratch first before I show you, because I don't want you to sit through the build. So Scratch is the base image. If you go Docker Hub and you start poking through all these distros like Ubuntu and DB and so on, you work your way up through the root, you end up at Scratch, right? From Scratch, they'll say. And this is an official Docker image. And as they say here, it's kind of the base image you build on, right? And as they say also, this is from their web page, the Confluence page or the GitHub Docker Hub page. Super minimal images that only contain a single binary and everything it requires, which is exactly what I'm doing, right? I have a single binary that's statically linked with everything it requires, and I can deploy that even on Scratch. And all that's going to happen is it's going to boot my app. That's all it's going to do. So I can do that too. So Scratch is essentially 0. It's not really 0. It looks like 0, but it has no size, right? Because there's nothing in there, just my executable. And since it's self-contained, it can work. So I can get this down to 19.4 megabytes to run. Same application, right? So we start off way off in the hundreds of megabytes range. I'm down to 19.4. It's a service. It has a REST endpoint, I can call it. There's one more thing I can do, though, right? I can use UPX again. So I can take that executable we've built. If I run a UPX on it, it takes from 19 down to about 5.5 meg. So now I've got a 5.5 megabyte executable, which on Scratch is about 5.5 megabytes, right? So let's go try it out. So let's go look over here. We'll bring this over. So a little bit simpler. Tool chain set up for musl. So you do have to, if you do use musl, you have to go grab the musl tool chain and install it. And it's not too tricky. And we have information in the GraalVM docs on. If you Google GraalVM static linking, you'll find our page, and it'll talk about setting up musl. Pretty easy. So static, the library is musl, the module, etc. Then I'm going to use UPX. And we played with UPX. It's really interesting. UPX has a lot of options around what kind of compression it uses. And one of our colleagues wrote a Medium blog that we've got in the GraalVM Medium blog, so medium.com/GraalVM. I think it's from a couple of years ago. He played with UPX with GraalVM Native Image, seeing, as he tweaked the options like more compression, less compression, spend more time compressing, spend less time, more or less time compressing. And he kind of came out with, well, this is sort of the best option. So it's pretty quick, and it produces pretty small executables. So I'm using those from this article that sort of steered me towards the best options. Take that static executable I've just built up here and then compress it, and then put it in a Docker file. And the Docker files, like they all are, kind of boring, right? So it's just copy the file in, grab the index file, boot, right? So let's build that. Oops. Let's go over here. See how small we can get this down here. And if you're paying close attention, you would notice that the C compiler here has changed. So the output from the compiler tells you you're not using the other GCC that I had before. Now I'm using the musl toolchain. Nothing's changed in terms of the class is reachable. This is a very deterministic experience here. Okay, it runs that. That took about 26 seconds as ever. UPX is crushing this thing down to about 1/4 of its normal size. Copy it in. Okay, let's see here. So let me jump to the top. Images. I got a couple, don't I? So I've got the JWeb server Scratch one. It's 5.5 meg. I'm going to run that. IP, just like I did when I had the full JRE, right, with JLink, same thing. And let's copy this name here. Okay. Boots, okay. Good. I shouldn't sound surprised. Good. I've done this before. It's going to work. And I can call it, right? Curl. Don't I have curl somewhere? Oh, curl. 8,000. Right? Serve the file. Okay, so it's working. And that Docker file, again, it was on Scratch, so it's 5.5 meg, right? Didn't we see that a minute ago? Yeah, so it's 5.5 meg. All right. So, yeah, that's what we got. Good. So here's what we saw. Okay, this is the journey we've just been on. So we started off with kind of the naive approach, which is I have an application, it's a Java app, I can run it on some slim image, Debian, you name it, slim, and I get the JDK and copy it all together and deploy it. And a lot of people do this. There's a lot in that Debian slim image you do not want in production. There's a lot in there, which is why there are others that have less. So it's way too big. We went to the distroless Java 17 image. So it's a base image that just contains Java 17 and just enough to run it, which I needed for my JWeb server to run, right? I needed that module, kind of large. And then you see we transition over here, and I actually have a few more in here that I maybe didn't show you today because there's a lot of steps. I kind of went through this process of like winnowing it down, right? How small can I go? What change can I make? We switch from the red to the green there when we move to GraalVM Native Image, and we continue to reduce the size of the application, right? So we then start using some of the GraalVM Native Image linking options to let us tune it down. What's interesting was when I statically link the application, it's much smaller than having it dynamically link in glibc, because that's quite large. So with musl, actually, the application doesn't seem to change much in size when I link in the required musl bits. So it's a huge difference, right? 385 meg down to 5.45. If you're building, say, serverless functions or things that need to react fast, and we were talking earlier with someone about building Alexa, what are they called? I don't remember the word there. Abilities of some sort, right? Skills, yes, they're basically lambdas. So you say Alexa, and then this thing transfers a container across the network somewhere, and then boots it up and goes, yeah, the temperature is 72 degrees Fahrenheit. If it's a 300 megabyte image, that takes a lot longer than the 5 megabyte image to transfer across and boot. And these things boot fast. You saw the boot time. The compression is not good, but skipping the compression, 20 meg is pretty good. It boots in like a couple of milliseconds. And so it's worthwhile. So this is not the full story. I didn't talk a lot about memory, like resource consumption with GraalVM, or I talked a little bit about the start time. But we see that we can create really small container images. Really the goal here is to build small that move around fast, that minimize your vulnerability, so we're stripping things out. If you're using a lot of libraries, a lot of third-party libraries, when you're running through GraalVM Native Image, we're stripping out a lot of classes that may have vulnerabilities. So we're working on some tools to give you some more insight into this, but the idea is that those ahead of time compiled binaries are a lot less insecure than the full JVM-based and jar-based systems. And yeah, so if you want to know some more, we have graalvm.org. So we have both open source community edition and the Oracle Enterprise edition, which has a few more optimizations and performance benefits. So graalvm.org or oracle.com/graalvm. And if you want to know more, there's another talk tomorrow by my colleagues, Thomas and Alina. That's on Wednesday, so there's a bit more. And that's all I have for you today. So I think we're on time. So I think we have time for questions. Any questions? Yes?
So hello world is pretty simple. What happens if you do reflection? Does it still work?
Yeah, so the question is, hello world is really simple. What happens if you use reflection? So this is one of the interesting things with GraalVM, often talked about, not often understood is the thing. So if we're doing static analysis, we're going to walk through the static references to classes. So your code, we can follow through and find everything. If you use a reflective invocation of a function or method, or load a class reflectively, then the static analysis doesn't know this. So we have a few solutions for this, right? One is you can tell us, hey, this class, we have a config file, this class has to be included because we know we're gonna want it. So it gets included and bundled into the binary. We've got an agent, which is lets you sort of monitor, like run on the JVM, we can watch your application and see what it's doing and capture the information. The thing we're working on now, focused on, is we've been working with the Spring team, the Micronaut teams, Halidon, Quarkus, to build basically a repository of the information for a lot of popular third-party libraries. When you use some third-party library, contains a bunch of reflection. We can, in the build tools we have, again, co-built with these frameworks. You're running Maven build, it'll consult this library and say, you're using this library, and we know that that has reflective use here, so we'll give you the config and it'll just magically work. So we're kind of in the early days of this. We're working around the problem, but there's some challenges. But it doesn't seem to be a showstopper, it's just a bit annoying, basically. Yes, way back there. Is the Debian one the smallest possible Docker container? It was the distroless one, right? So distroless, the distroless static was about 2.5 meg. It was Debian at the core. It was a Debian distro, but they stripped it down. So that was the smallest Debian distro I used. It didn't contain glibc. It didn't contain much of anything. That one seems to be the smallest one, right? So if you go looking at you can go to you can get OpenJDK images, you can get all kinds of images. That distroless one for Java seemed to be the smallest one that I could see. But I mean, your mileage may vary. Yeah. Yes.
Modeler is the GraalVM runtime library. For example, if I now select the epsilon GC, which is a lot simpler GC, can I then still reduce the size more, or is that all part of that runtime library?
So the question is, how modular is the GraalVM runtime? And if I change the garbage collection algorithm, do I change the size? Can I change it, right? Yeah, so if you, in the enterprise edition, you can use G1. So we have serial in the base one, which is pretty good for smaller things with smaller heaps, especially for things that run in as services for short times. You can use G1, it will get a bit bigger. But you're just linking in code, right? So of course, yeah, it'll get a bit bigger. Epsilon, I think it would be smaller. Yeah, doesn't do much. But this is kind of the thing. It's kind of interesting. If you have a function that only lives for a short period, why bother garbage collecting? I know it's often, yeah, for sure. Anything else? Okay, I'll say thanks very much. Thanks for staying late. Thank you.